Hello everybody, my name is Frank Oliveira and I represent the work developed by me and Professor Daniel Gouveia Costa, named Towards Sustainable Cycling, Modeling and Visualization Issues of Cyclepaths for IoT-Based Sensing. As you can see in the overview slide, I will talk about the work problem scope, the proposed mathematical modeling, a bike-centric IoT-based sensing application, a data visualization in cyclepaths, simulation results, and finally the conclusions. Following the topics presented in the previous slide, let's talk about the problem scope presenting the motivations and the goal of this work. Nowadays, it's a fact that the city presents a scenario of many adverse environmental conditions such as extreme weather, air, and noise pollution. Among the main causes of this current situation in cities, we can mention the high numbers of motor vehicles on the streets and industries, which are the largest emitters of polluting gases in the world. Knowing the city scenario of pollution and extreme climate, some negative impacts can affect the population, especially cyclists who are completely unprotected when traveling on the streets. These impacts are directly associated with the cyclist health, that when breathing polluted air may develop cardiorespiratory problems, or when inserted in a very noisy traffic environment may develop hearing problems, or when cycling in extreme heat or very high levels of ultraviolet radiation can dehydrate, pass out, or develop skin cancer. With all these presented problems, it is extremely important to monitor the environmental conditions that can affect the cyclist health and the population in general. Thus, climate change and excessive pollution have raised some concerns which are the current environmental conditions in our city adequate? How are the environmental conditions evolving over time? How these factors impact cyclist health? In this way, new solutions can provide valuable data for such questions, make it possible to capture data in the form of environmental variables, store and process that continuously and distributively, make data available to governments and the inhabitants. These solutions can be implemented from the concept of smart cities, which is based on the foundation that cities have technologies capable of monitoring and managing resources in order to bring a better experience to the inhabitants. From the application of the Internet of Things, it becomes possible to develop applications such as public safety, urban mobility, waste management, and environmental monitoring. It is the focus of this work. In this way, this work proposes solutions for some important modeling and visualization issues related to the quality monitoring of cyclepaths. For this, we can divide this work into three parts. The first one consists of a mathematical model developed to represent the cyclepaths, as well as the process of registering and importing these models into a software. The second part is related to an IoT-based system capable of capturing environmental information through multi-sensor units coupled to bicycles. Finally, the third part consists of a web application capable of processing environmental monitoring information and transforming them into maps and charts for better visualization by the user end, which can be cyclist or government management. For a better understanding, the first part of the solution developed in this work to be presented will be the mathematical model of the cyclepaths. In the context of this work, a cyclepath is defined by an undirected graph C that has a set of endpoints that generate n-1 edges or stretches of the cyclepaths. For a point Pi, represented by a geographic coordinate, there is a point Pi plus 1 forming a cyclepath stretch Si which stores monitoring data. Once the mathematical model was defined, we started to design the process of registering the cyclepaths through software. This process has three fundamental parts for the development of the task. The first part is the cyclepath registration app, which can be a web page that allows mark the points and edges of cyclepaths on a map, for example. The second part consists of the database that we receive and group the JSON files that store the cyclepath models in order to send it to the consumer apps. From a mathematical model of cyclepaths and the well-defined registration process, process of this, it becomes possible to link georeference the monitoring samples to each thread of psychopaths. For this, it is first necessary to develop a system for collecting this environmental data, which is proposed in this work as the bike-centric IoT-based sensing application. The main features of this system-enabled bike sensor are distributed georeference multi-sensors attached to the bikes, continuous collection of environmental monitoring data, offline operation, grouping data from multiple bikes into a unified database, delivery of data to end users through client applications. To fulfill these characteristics, bike sensor is divided into a monitoring mobile station attached to the bikes for collecting environmental data and storage in CSV files, a data center unit which is responsible to store all MMS CSV files sent through Wi-Fi communication, and a bike sensor client, which is an application that will process and present monitoring data. Once the data referring to the psychopaths model and the environmental information are able to acquire by the systems and the process presented, it becomes possible to process them and allow the visualization in the psychopaths. For this, the cycling view was created. This application is capable of processing data from psychopath registration and the IoT-based monitoring applications, map generation for better visualization of the processed data, and information delivery through a web visualization app. In this slide, it's possible to see that the cycling view receives data from the psychopaths registration tool and from the environmental data collection tool. Once the both data was received, the data processor model makes the data fusion for map generation and delivery to the end users through the visualization app. The map generation process consists of verifying the belonging of each monitoring sample collected by the MMSs attached to the bikes to a certain stretch of a certain registered psychopath. For this, we developed an algorithm to calculate the distance between the monitoring point MP and a psychopath thread through the relation of the right triangle that is formally equal to what is present in this slide. Through this distance d, it is possible to define whether the monitoring point belongs to a specific stretch of psychopath. This distance d must be less than a predefined distance big G. Knowing how this verification is performed, the map generation model has a sequence of steps to be followed so that all monitoring samples can be associated with their respective registered psychopaths. First, the cycling monitoring data are imported from their respective tools. After importing data, a translation of the geographic coordinate of the monitoring points is performed to identify which city these samples belong to. Once this data is translated, only samples that are located in the cities with the registered psychopaths are passed to the next step. This step consists of checking the distance between each monitoring point and the psychopath threads in the city to which the sample belongs. Once it is identified that the monitoring points belong to a stretch of a bike path, it is stored so that it can be exported together with others in the same situation. With the process of generating the map completed, the final result is the map shown on the current slide. In this one, it's possible to see the registered psychopath, the monitoring points that belong to the psychopath, and finally, a chart that represents the daily history of a certain environmental variable in that place. Once the solution for modeling, monitoring, and visualizing the environmental quality of bike paths have been presented, I will show the results acquired through the simulation. Due to the COVID-19 pandemic, it became possible to carry out monitoring data collection through MMS attached to the bike of volunteer cyclists. Thus, the test process of the solution proposed in this work consisted of a simulated data collection based on the following actions: manual registration of 5 psychopaths in Feira de Santana, Brazil, simulation of 5 monitoring units collecting data, collection of environmental data from the city via internet, execution of the proposed solution with simulated data. For this process, the 5 registered cycle paths were chosen based on some criteria that can influence their quality. The first criterion is the place where the cycle path is located, such as street, avenue, park, or university. For each of these places, a different flow of cars is forced, causing different air and noise pollution impacts. Furthermore, the amount of vegetation or shade was considered, which can mitigate the impact of weather conditions in that place. As can be seen, for this simulation we choose 3 cycle paths in an avenue, 1 cycle path in a park, and 1 cycle path in a university. In this case, the cycle paths located in the park and the university are expected to be better than others. Once the cycle paths were chosen according to the defined criteria, monitoring data were collected in AccuWeather and other more specific databases. These data were collected from the average of a given day for the following environmental variables: noise pollution, air pollution, ultraviolet levels, thermal sensation, and luminosity. In the air pollution map presented in this slide, it is possible to identify the position of each registered cycle path. As can be seen, the C5 and the C3 cycle paths have the best levels of air pollution, as they are located in a university and in a park. Even so, the air pollution levels of the other cycle paths are considered good. In this map, it is possible to see that the cycle path inserted into a main avenue has moderate to high levels of noise pollution, while the other cycle paths have good to excellent levels. This is mainly due to the intensive flow of vehicles in this region. As for the UV radiation map, it is possible to see that the levels are moderate to high in all cycle paths. This is due to the fact that Feira Santana is a city located close to the equator line and it has high levels of UV radiation. The same situation of UV index applies to the thermal sensation map, since this variable is also related to the region's climate. This way, all cycle paths have good levels of thermal sensation as presented in this slide. Finally, in the luminosity map, it is possible to see that all the bike paths have good light, with the emphasis of the cycle path located on the main avenue. In this way, the simulation made to verify the function of the solution proposed in this work presents several perspectives of quality of cycle paths that were partially validated. This way, all results are according to what was predicted for each type of cycle path chosen. With the solution validated through the simulated results, we can advance to conclusions reached with the development of this work. As a discussion, we present the following research points. We proposed the mathematical model and an algorithm to process cycle paths in an urban environment. The proposed algorithm for measuring environmental monitoring data through an IoT system and the cycle path registration data has great potential. The map visualization tool allows a better understanding of the cycle path's quality in a city and can be used for different purposes. However, although the results achieved in this work are satisfactory, further work is planned to complement the gaps that remain due to the COVID-19 pandemic. As future works, the development of the cycle path registration system following the presented process is planned, which can be implemented as a web tool for marking the cycle paths. In addition, the implementation of bike sensor is also planned using bicycles for volunteer cyclists in order to collect real data. In this way, it becomes possible to implement the entire proposed solution in a city in order to collect data that can guide cyclists to choose the healthiest routes and bike path administrations to improve their situation. In fact, this is a work that has a great potential due to its current technological and sustainable nature. In this way, it becomes possible to develop the most diverse solution that seek to improve the conditions of cycle paths in cities. So, otherwise, thank you very much for your attention, and if you have any question, please do not hesitate to contact us through the emails presented here.